Okay, so let's look at number 5. Number 5 says find the volume of the solid generated by revolving the region bounded by these three graphs of the equations about the y-axis. So 3 times 2 minus x is the same thing as if I were to distribute this 3. So if I distributed this 3, I would have y is equal to 6 minus 3x, otherwise negative 3x plus 6 in y-intercept form, like y equals mx plus b. So over here, you notice on the y-axis at 6, I am going through the graph, and I have a slope of 3. So down 3 over 1, down 3 over 1, so on and so forth. Okay. In my blue function, I have y is equal to 0, aka what you see here as the x-axis. And then x is equal to 0. Right here is my y-axis as far as that vertical line. The region that is shaded is in orange that's bounded by all of these three graphs, if you will. These are going to create this triangle that I'm now going to rotate or revolve about the y-axis. So the y-axis, this is going to come out of the page, and then it's going to go around the y-axis, out of the page, and then it's going to go around the y-axis. That's what it's going to look like as it revolves, okay? So because these are parallel with the x or perpendicular with the y, however you want to see it, these are going to be horizontal slices that are with dy. So it's in respect to y. So we have to come up with functions that are in terms of y. Okay, so that means we're going to solve for x and get some of these functions like up here with x all by itself. So I can go ahead and subtract 6, and then I can divide by a negative 3. So I'd have negative 1/3 y plus 2. And these are the same functions, if you will, or graphs, but they're in terms of y rather than in terms of x. So again, in terms of x is whenever you get y by itself. In terms of y is when you get x all by itself. Okay, so let's go ahead and set this up. We know it's a disk method, okay? This axis of revolution, let me highlight that in orange, is the y-axis. And it is right here touching entirely, it's touching. So again, we're revolving around the y-axis. And everywhere in this current orange region, this shaded region, it is in fact touching the entire shaded region is touching that axis of revolution. There are no voids, there are no gaps, so this is going to be a disk method. So it's like some kind of pi r squared. We just have to come up with what is that pi, or sorry, what is that r that is. So r squared, let me go ahead and move that dy just a little bit over, and we're trying to build these horizontal slices, okay? So just like before in other problems, we're going to go ahead and draw a straight line from the axis of revolution, which is in this case the y-axis, to the outermost rim of the shaded region, and then we stop. Then we will put that it intersects the red graph there, it intersects that green graph there, and now because this is dy, otherwise horizontal slices, we know that this right here becomes the top. So it's like you rotate your head, and this right here will become the top, okay? So looking at that, the top function is going to be the red function, not the green, but we need it to be in terms of y. So notice how we solve for that x, so that we got the top was negative y over 3 plus 2. That's the top function. And we're going to subtract the bottom function. Again, we have to rotate our head. Remember that this is now the new top because you rotate it 90 degrees. And then that your bottom function becomes the green one, which in this case is the y-axis, which in this case is 0, okay? So that's top minus bottom. It is pi r squared, and if I revolve around it, it will give me the answer, which I'm going to go ahead and plug it into my calculator, of something units cubed. The only thing that I have to do at the very end is I have to make sure that I have my limits of integration. I need to know, since I'm in respect to y, that I'm looking for what is the low y and the high y value, okay? So I do not interpret these with the rotation 90 degrees to the right. This is going to be just normal looking at the graph with the y-axis being the top up here. So I'm looking at just as normal face value, okay? And I want to know, what is my lowest y value all the way up to my highest y value in this interval? Okay, so obviously the lowest y value is 0, and the highest would be 6, because that's where it crosses the y-axis. That's where this graph here that was originally given crosses the y-axis. So this would be from 0 to 6. Okay, so let's go ahead and go in the calculator. We're going to set this integral up. Let's put a pi out in front. And it is, going to be from 0 to 6. And it's pi r squared. So we need, this huge thing will be r. It is dy. And now I just need a top minus the bottom. Okay. And the top on this one was that right here, negative y over 3 plus 2. So we have negative control divide y over 3 plus 2. And then that bottom function was just 0 because it was the y-axis. Otherwise, x equals 0. Okay. And then when I press enter, I get 8 pi. So my answer to this is going to be 8 pi units cubed. All right. So that's how you do this one.